Okay, let's try this with Desmos. So if we have a function that looks like this, y equals a times x minus h, and then we will square that baby, and then add on k. It'd be interesting to know what this function actually looks like. So I'm going to make sliders for a, h, and k. And here's the thing that's really cool is h and k. If h is set to 0, and by the way, let me make it so that this goes just one at a time, and we'll do the same thing over here, step 1. And when we do that, there we go. When we do that, now it makes it so I can get, I don't have to worry about decimals. So look, when h is 0 and k is 0, I get my vertexes right here at 0, 0. Let's make it so you can see that nice and thick there, okay? And remember that this h is 0 and this k is now 0. And then if I move the h around, if I make h like 1, 2, 3, 4, 5, then my vertex is now at x is 5, y is 0. So the h is kind of like the x coordinate of the vertex, and the k is the y coordinate of the vertex. Again, let's try something different. I'll bring the h back to 0, and I'll move k up. So there we go. K is going up to 5. Okay, and but something is sort of interesting about. Again, notice 0 and 5, 0 and 5. There is one little trick that's interesting though, is notice that it's a minus sign that's very important here. So only when there's a minus sign there does my h going up make the x go up. If for some reason that is a plus sign, then things work backwards. As my x value goes 1, 2, 3, 4, 5, my vertex moves to my actual parabola and vertex moves to the left. So anyways, it's worth playing around with to get a feel for it. In general, the idea is that when you have whatever your h value is, let's take another look. So what if I have y equals x plus 3, and then I square that, and then I say plus 2. Okay, if you had to identify the vertex of this particular graph, you would say it's at the vertex here is at x is negative 3 and y is 2. That gets us the vertex for the orange parabola. Okay, and if we said the other way around, that it's that x is minus 3, then of course our vertex would be at 3 comma 2, and I'll go ahead and I'll put a dot there so you can see that. Okay, so that's how the h and the k works for vertex form. And then the a, it does some interesting things too. Watch what happens as a gets bigger. As a gets bigger, my parabola gets narrower. As the a gets smaller, then it gets wider. Now, when a gets negative, all of a sudden the parabola flips over, so we get a frowny face parabola. That should be in line with what we learned about parabolas in the past. If a is positive, we get a smiley face. If a is negative, we get a frowny face. So that much is still true. Now, one thing that's really interesting though is let's take a look at, let's go steps of like 0.1, and we'll go from, let's go from negative 1 to positive 1. And we're going to take a look at that. Okay, now look what happens here is that as we get even as we're getting closer and closer to 0, our parabola is getting wider and wider all the way until we get to 0. And then again, the parabola starts out wide and gets skinnier and skinnier and skinnier. Okay, so that's how a affects the parabola. And again, it's worthwhile for you to play with in Desmos yourself to get a feel for it. Another thing that I'd like you to take note of here is that here we have a, well, let's make a couple different parabolas. So I'm going to go ahead and turn off that red one, and I'm going to see if I can move this guy up, and we'll make another new one. Let's go ahead and add a parabola, and we'll say y equals, let's do x plus 4, we'll do squared, and then minus 1. Okay, so now we have two different parabolas that we can compare. What I want you to notice is that for these two parabolas, the shape of the parabola is the same. And the reason for that is the a value is the same. There's a 1 here and there's a 1 here. And for that reason, the shape is the same. Even if I change this to 2/3 and change this one to 2/3, they both get wide at about the same rate. But what's really interesting is they're translated. Remember that term from geometry? If we go from, let's see, let's start with, I'm going to make this parabola number 1. If we go from the red parabola to the yellow parabola, if we go from here to here, all that happens is there's a translation. In other words, we shift. We shift in one direction, either to the right or left, and we shift either up or down. In this case, if we were to describe our shifting from this parabola to this parabola, we would say that the shift goes to the right, 1, 2, 3, 4, 5, 6, 7, and I'd like you to write that down. Pause the video if you need to. We would also then say that the translation goes up from here, 1, 2, 3. So shift to the right, 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3. That's how we would describe the translation between this quadratic function and this quadratic function. So I would love to tell you a lot more about the vertex form of quadratic functions, but what I'd like to do is in another video I'd like to show you how to convert from the standard form of a quadratic function into this vertex form, which makes it easier to graph and understand. Oh, one last thing I would like to say before I leave this video is that this number right here, the 4 or the -3, what happens there is that number is the h value, it does happen to be the same as our axis of symmetry. So if I type x equals -4, and then let's go ahead and make that a dashed line. If I do that, see this dashed line that I get there? That's the axis of symmetry for this parabola, and it just happens to be exactly where h is, at -4. H is -4 here. And if I change that to +3, here h is +3, then I get the axis of symmetry for that parabola. So I'd like it if you wrote in your notes that the h value in vertex form is also what x is equal to for the axis of symmetry. That could be useful for you. Oh, and one other thing is this number here is not the y-intercept. It's very easy to check for yourself. You'll notice here for this red guy, we do have a y-intercept. It looks like it's at about nearly 10. And on this red guy here, you can see it says -1. So clearly this number here is not the y-intercept. If you want to find the y-intercept, plug 0 in here and then do the math, and then you'll get the y-intercept. Okay, that's all I got. Let's learn how to convert from standard form to vertex form.